All right, we're in part 3 of the review video. Number 17. So here we have expressions written with rational exponents, which means fractional exponents for 17, right? And we need to simplify, and we need to watch if we have to rationalize the denominator. So if I have a quotient where the base is the same, if I have a quotient, I subtract those exponents, don't I? So that is 8 to the negative 1/3. Well, in the instructions, it should be clear that you don't want to leave negative exponents in any answer. So a negative exponent, to get rid of it, I change its position in the fraction. Okay? So this is what the answer looks like. But notice, 8 to the 1/3 really is the third root of 8, isn't it? So this answer would be the third root of 8 is 2. Okay? All right, 18. Let's look at 18. Now, if I have this quotient underneath the radical, I can rewrite it as the 4th root of 16, excuse me, over the 4th root of x to the 14th, right? Well, the 4th root of 16 is straightforward, fortunately. It's 2, right? 2 times 2 is 4, times 2 is 8, times 2 is 16. The denominator is a little, got to do a little bit more work. So I'm going to look for all the perfect x to the 4s underneath here. So I have the 4th root of x to the 14th. So that's x to the 4th, right? Times x to the 4th, times x to the 4th, times x squared, right? That's 12, that's x to the 14th. Okay, well, the 4th root of x to the 4th is x. The 4th root of x to the 4th is x. The 4th root of x to the 4th is x. And then I have an x squared under an so this becomes times x to the 2 over 4, which is 1/2, isn't it? All right. Now, so that's 2 over, I have x to the 3rd times x to the 1/2. Well, x to the 1/2 is the square root of x. I need to rationalize the denominator. So to get this to be a full integer in the denominator, I'm going to multiply by x to the 1/2. Okay? So my numerator is 2x to the 1/2. My denominator, that's an x to the 1, isn't it? Times an x to the 3 is an x to the 4. That should be my answer. All right, let's look at this one. Can't keep giving myself extra room. Now it says, write each expression in radical form. It's already written in radical form. All right, our first step is I can rewrite this as 2 to the negative 3 over 4 over 2 to the negative 7 over 4, all under that square root, right? And when I have a quotient with fractional exponents, I subtract the exponents. So I'm going to come over here, and it's minus a negative 7 over 4. This is all under my square root, isn't it? All right. 2 negative 3 over 4 plus 7 over 4. It's negative 3 over 4 plus 7 over 4 is 4 over 4 is square root of 2. All right, let's look at this one. I'm going to come back to 20 because I'm really not sure what they're asking us to do there. Actually, that problem looks really similar like we've done it before. I'm going to go back for a second. Yeah, there's no way for me to combine that in one radical because we have different roots. So we're going to come back to that one. Let's move on to 21. Let me pull this down to its own sheet. And it says solve the equation. This was 11.3 go back and check for extraneous solutions. So 21. Hey, this is beautiful. The radical is all by itself. It's a square root. I'm going to square both sides, right? So 5x equals 100. I'll divide by 5. X equals 20. But I need to check. So I'm going to come over here. I'm going to say 5 times 20 under the square root. Does that equal 10? Square root of 100 equals 10. Bam. That one works. All right, let's look at 22. All right, what's interesting here, I can square both sides, can I? I get 2x plus 5 equals 3x minus 1. So I'm going to subtract 2x. And I'm going to add 1. So I should have x equals 6. Okay, let's check it. 2 times 6 plus 5. Does that equal 3 times 6 minus 1? 12 plus 5 is 17. Does that equal 18 minus 1 is 17? It does. So we're good, right? Okay, let's come down here. Get this one out of the way. All right, now when we're working with rational exponents, we kind of follow the same process. I need to get this by itself. So I'm going to divide by 4. X minus 12 to the 1/3 equals -4. Geez, I'm getting a little messy here, folks. Sorry. -4. All right. Well, I'm going to raise it to the 3rd power, right? I'm cubing. Because 1/3 times 3 over 1 is 1. So this is x minus 12 equals -64. Let's add 12. All right, so that's going to be -52. So now let's check our answer. Okay. 4 times 52 minus 12, the cube root. Wow, I'm thinking ahead in my, it's -52 minus 12. Does that equal -16? All right, 4 times -52 minus 12 is -64. To the 1/3. Does that equal -16? Well, the cube root of -64 is -4, so it works, right? All right, let's try this one. Number 24. It's a square root. I square both sides. I square both sides. I have to remember here that I'm foiling. So it's -14x plus 2. If I FOIL this, I get x squared minus 6x plus 9. So I have a quadratic. I got to get everything over to one side, don't I? All right. Oh, this is nice. I can factor this. So x equals -7 or -1. But now I have to see if these work, right? So I'm going to check -7. -14 is -7. Well, gang, notice what we have here. We have a radical on this side equaling -10. That can't work. And if we plug -1 on that right-hand side, that can't work. So this problem has no solution. Okay? Last problem. Again, square root. We square both sides. X minus 3. Oh, come on. Sorry, I gotta get off of this thing. There we go. X minus 3. Goodness gracious. X minus... I don't know why it's doing that. Let's see if I come over here. Alright, well, x minus 3. I'm going to FOIL. Let's do this. Alright, x minus 3. Now FOIL this side, right? Make sure you're foiling it. It's x squared plus 2x plus 1. So I'm going to get everything. Why is it doing this? Everything on one side, I want it to equal 0. Oh, this is really weird. 0. X squared, I'm going to subtract x, plus x, I'm going to add 3, plus 4. Oh, dang. I can't factor that. I would have to use the quadratic formula. Right, so negative b plus or minus the square root of b squared minus 4 times 1 times c, all over 2 times 1. This is going to be negative. These are all imaginary solutions. So in this case, there's no solution because we were looking for reals. Okay? We will go through these, or we will have gone through these in our Microsoft Teams session. But this record is for you to use. All right? If you have any questions, let me know. Thank you.